Number 2, there are 2 triangles. Here's one of them. Actually, there are 3, but we're only going to pay attention to 2 of them. Here's one. Here's another. The third one is just a big triangle. Well, we don't need to worry about the big triangle. It says, solve for x and write your answer in simplest radical form. So we need to figure out what x is. So my first thought is, okay, this triangle, I can use Pythagorean Theorem. If I only knew this side, it makes this type of triangle. That would be x. But I need to know this. I need to know that side. So that's one triangle, but I can't use it yet. I'm missing 2 sides. However, there's another triangle that is this, where the bottom is 3, the hypotenuse is the square root of 34, and I don't know this side. So, I can still use the Pythagorean Theorem. Maybe this will be A, the 3 will be A. I'll say this is B, and C is the square root of 34. Here's the thing that people, if they understood that, they might have messed this part up. If I try to write down a squared plus b squared equals c squared, first of all, c is always across from the right angle. Someone in my other period was saying they think of the right angle as like an arrow. It always points to C. It always points to the hypotenuse. That's one way you can tell. So, whatever the square root of 34 is, that's what C is. And if I write a squared plus b squared equals c squared, okay, that would be 3 squared plus b squared, that's not a 6, that's b squared, equals the square root of 34 squared. That's what confused people. This right here. But look, I'm going to show you on my calculator. Can you see this, hopefully? If I do the square root, first turn it on. If I do the square root of 34, and I push enter, that gives me some weird decimal. But I'm not looking at the square root of 34. I'm looking at the square root of 34 squared. So I'm going to type that in. The square root of 34 squared. Watch what happens. Square root of 34 squared. Hit enter. It gives me regular 34. It's amazing. The problem got easier. It's easier now. So this becomes 9. That's still b squared. And then I have regular 34 on this one. Because the square root, when you square it, it goes away. Questions on that? Okay, then I can solve for b squared by subtracting 9. No, it's not 9 times b squared, it's 9 plus b squared, so you subtract it. B squared equals, what is that, 20? Is that 20? 14, 13, 12, 11, 10, 9, 8. It's 5, 25. Ooh. That's 25, yeah? And then square root both sides. Always, whenever you're putting in the square root, try it in the calculator. Try it. If you do the square root of 25, that gives you regular 5. The problem is still easy. Well, if you understood this far. So, what the heck does that mean? This side length, I'm going to have to get a new paper. That side length is 5, which means in my picture here, that side length is 5, which also means, dun, 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 now I can solve for x in this triangle. So, the key here is to split it up in 2 triangles and see whichever one you have enough information for, that's the one you start working on. So, we stopped with, or we just got the other side for this second triangle. The whole idea was to split up the two triangles and work with whichever one you have the most information about. And that was this smaller triangle. And we could figure out that one side. That side gave us a side for the other triangle. Now I can do a squared plus b squared equals c squared again. So I'll call this a, b, and c. Again, c is always across from the right angle. You can think of this as a little arrow pointing. So then I would have x squared, that's a squared, plus 5 squared equals c squared, 11 squared. When I saw people doing this, they had like x squared equals 5 squared plus 11 squared. That's wrong. Make sure you're choosing the proper value for c. Once you have this, you would, I guess, multiply this out. So that's 25 and 121. Subtract 25. So we have x squared equals, what is that, 11, 10, 9, 8, 7, 6. Is that right? 11, 10, 9, 96? Yeah. Square root both sides. Square root, and now I can start to break this down. And this is just simplifying a radical now. So my first thought is, I don't know, 96, I could divide it by 2. That would be 45, 46, 47, 48. I can break the 48 into, I guess, 4 and 12. Anytime I break something down, I don't need it anymore. So I need this 2. The 4 and the 12. I can break the 4 down into 2 and 2. I don't need the 4 anymore. The 12 I can break down to 2 and 6. And then the 6 into 2 and 3. So I don't need that. I don't need that. I broke that down. So I'm circling the pairs. So 2. I'm circling another pair. And then the leftovers are the 3 and this 2. So I have, I'm just going to take up this room. 2 squared, that's from this, done. 2 squared from that. And then 3 and a 2 on the inside of the square root. But the things that are squared, just like I squared something with a square on the outside and a radical on the inside, they cancel. Same thing here, they cancel, and then I can bring it out. So I get 2 on the outside, 2 on the outside, and 3 times 2 on the inside, which is 4 square root 6. So x equals 4 square root 6. That's for this problem. Normally I wouldn't have written so much, but I was trying to explain. So that's the end of that one.